Hi, my name is Michael. I'm one of the leaders of native robotics. Today I will show you our new tool, OmniWeb. You can use it to connect with your customers anywhere in the world and co-create engaging palletizing simulations. I will show you three things. First, we will cover how you can input parameters of your system. Second, how you can select different components and place your robot. Finally, I will show you some analytics which you can do and explain how you can share the video with your client. To start working with the tool, you will need a PC and a web browser. We currently support Google Chrome, Firefox, and Opera. Click on the link below to start.
Once you access the link, on the first screen you'll see a list of saved layouts from previous simulations. Since this will be our first time doing the simulation, this list will be empty. Click on the new layout to create one. On the second screen you can input the parameters of your boxes on the left. Note that the dimensions of the box are specified in millimeters and the mass of the box is specified in grams. You can also move your label to either side of the box. Once configuration is done, click Continue. On the next screen, you can select your palette. It can be a European palette or an American one. For the purposes of this demonstration, I will use a Euro palette. On the fourth screen, you can create your layout. Drag and drop the boxes from your right onto the palette. You can also specify the exact position of each box by using the menu on the left over here. You can rotate the box if needed. Click a line to make sure that the boxes are in the center of the palette. You can use our Magic Pack function to pre-populate the palette with a default layout. Let's clear the palette first and then click Magic Pack. Finally, let's click Faces Out, so the labels will be facing outwards. Click Continue once ready. Here you can select the number of layers for your palette. Click and drag the slider on your right. You can place a slip sheet by clicking on each layer. And you can also select different mirroring for the layers. Click Continue. We arrive on the simulation screen. You will see a frame by Easy Palletizer, a UR10E, and a Schmaltz gripper. Let's customize this simulation first. So click on the End of Arm tool and select different gripper at the bottom of the screen. I will go with the gripper number 1 by OnRobot. Then click on the base of the robot, where you can select different cobots. So either UR10, UR10E, or UR16. I'll go with the UR10E. Then click on the frame itself, and here you can also select different frames. I'll go with just a simple SKF column by Avalix. Now we can do some advanced customization. So let's say we want to place the robot perpendicular to the conveyor. So click on the gear icon on the top, click on the box parameters. You will see here specification X, Y, Z, RX, RY, RZ. So these variables define where the robot will pick the box. Let's say we want to place the box a bit further away from the robot and rotate its position by 90 degrees. And as you can see, the position of conveyor has changed. You can do the same for pallets, for pallet A and for pallet B. And finally, we can enable or disable the column. Let's disable it for a moment. Now we can do some analytics. So click on Check Feasibility to make sure that the robot will actually reach all positions. And since we disabled the column and since our pallet is quite tall, you see that the robot won't be able to reach the upper layers. Let's fix that. So first, click on the gear icon, select the column over here and click Enabled. We can do the check feasibility again. Will that do the trick? Nope, we still have a couple of boxes which are not reachable with the standard 0.7 meters column. So let's plug in 1 meter column as maximum height and do the check feasibility again. So this should solve this issue. All right, so we are almost ready to start the simulation. We need to make sure that the robot speed will be consistent with the real speed. To do that, click on the gear icon, select your robot, make sure that movement speed is specified actually as 0.9 over here. Then click on the box and under reset parameter specify 1 second. So this is needed so our simulation speed will be consistent with the real speed of the robot. Once this is done, you can click on Start Simulation at the top of the screen. The robot will recognize the position where it needs to pick the box and the position of each pallet and start palletization. On the left, you'll see runtime statistics. Please note that the speed right now is indicative. So if you want to know the exact speed of the robot, we ask you to do a more detailed simulation than this one. Now you can record the video of this simulation and send it to a client. Press Windows G to get the standard tool, which is available on Windows 10. And over here, you'll see Start Recording button, which will allow you to capture the video from your screen. Press Escape to exit this view. So this is it. The simulation is ready and we can send it. That was pretty quick configuration of a palletizer, was it not? Now the cool part is we can actually do the same with a real robot. So if you'd like to learn more, contact us today and we can do a demo with you. Thank you.